Hello, everyone. Thanks for joining us for our next live session. I'll be your producer for our session, but before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer. Our session is being recorded. It will be available to view on demand right here on the Microsoft Reactor channel. With that, I'll turn it over to our speaker for today. Thanks for joining us.
Hello. Welcome, everyone. Thanks for joining us. Carlotta here from Lecce, Italy, and I'm an AI advocate in the core AI DevRel team, and I'm very glad to have here my teammate Nitya with me. Hi, Nitya, how are you doing?
Hi, Carlotta. Yep, I'm doing good. I envy you, Italy weather. I'm in New York, and it's freezing, but we're so excited to be here today to talk to you about all things Azure.
Yes. So let us know where you're joining from. We are glad to have you here today. And we're going to walk through a comprehensive guide on maximizing the cost efficiency of AI agents on Azure today. This is based on a Microsoft learning path of the same name. And you have the link at the bottom of the screen, and you have the QR code as well to look at the Microsoft Learn training path. So maybe later on you can review the content at your own pace. And this learning path covers everything from identifying the right use cases to optimizing your ongoing investment for Agentic AI. And we're going to ground the entire talk today in a realistic enterprise scenario, so you can see how these concepts kind of apply into practice. So let's dive in. So we have someone from Düsseldorf, Singapore. Hello, welcome. Okay, so as I said, we're going to dive into kind of a real-world scenario. So let me introduce you to this business scenario. We are, Nitya and myself, we are going to pretend to be, to work for this Zava DIY retailer, which is a mid to large DIY retailer where stores across the globe and an e-commerce platform, and they want to automatize and optimize 4 key business areas: customer service, return fraud detection, product and safety compliance, and sales analysis and inventory management. And so, like many enterprises, they face both business challenges and technical challenges. So I'm going to act as the executive or decision maker for Zava. So I'm going to take care about business challenges. Nitya will walk through some of the main technical challenges and how to address them. So we are going to follow, Zava's journey through each of these challenges. And in terms of, business challenges, we are going to face things like limited AI budget, we have high expectation from leadership, and a need to prove ROI to the board. We need to scale across 4 different business units, which are the 4 business workflows you see on this slide, and also regulatory compliance requirement. In terms of technical challenges, we're going to see, challenges about integrating AI with existing system, ensuring data privacy and security, and also managing the whole life cycle of models. So here's our kind of complete agenda, our roadmap. We have 7 modules to cover, and for each module, we are going to try to answer a specific question. So we're going to start with the question, is Agentic AI the right choice for my business scenario? And if so, which scenario I should prioritize? We're going to understand the key cost drivers, learn how to forecast ROI, and we're going to see some frameworks that can help us manage both the business and technical challenges of our project. And then we're going to deep dive. Nidya is going to deep dive and cover kind of the technical perspective. So we're going to see things like which development approach to choose, either build, adopt, or extend an agent, some scalable solutions, some scalable architectures, and how to control cost into production. And then we're going to wrap up with a knowledge check. So, we're going to see if we learned something today. And let me start with the first question, which is one of the most important questions we should answer, before starting. We have 4 agents idea. Which one is worth, or for which one makes sense to build an agent, and where to start? One of our recommendations, like as a first step, is research. So Zava shouldn't start, from scratch or reinvent the wheel. They should look at what other retail companies have done with their agents, and they can do so by using the Microsoft Customer Success Stories portal. And you have the link in here, the ak.ms link, where basically they can look at they can filter by industry, product, and region, narrow down their research, and look at other companies' experience. So Zava can find examples of other DIY retailers and home improvement companies that have deployed, similar agents, and so learn from their outcomes. And equally important is the internal collaboration across different teams. So the customer service, the store managers, the product safety officers, they all need to kind of share the learning experiences. Things like, where are the biggest pain points? Where is the manual work consuming the most time and introducing the most errors? So what are the business needs before kind of converting them in technical requirements? Zava evaluates each of the 4 agent ideas through 6 main lenses. First of all, does implementing an agentic AI solution for that specific scenario reduce overhead? So, for example, the customer service agent could eliminate manual data entry, which is a huge time sink. Another question is, does it streamline resource allocation? So, for example, rather than building one massive agent, they could deploy modular task-specific agents. Third, they should think about scalability. So, can it auto-scale during peak periods like Black Friday, for example? The fourth lens is productivity. So, automating repetitive tasks like return verification. Then we have customer satisfaction. Agentic AI, allows to offer 24/7 support with customized, personalized support as well. And fifth, we have a revenue growth. So can the agent identify cross-sell opportunities or predict churn, for example? So by scoring each use case against these 6 criteria, Zava can objectively compare these 4 agent ideas. And so now let's do like a practical example. Let's analyze 2 specific use cases. And now I need your help, Nitya, to really understand from within these 2, our team proposed 2 agent ideas. We have a customer service shopping assistant, so assisting, Zava customers with the product catalog. So, for example, retrieving description of products and suggesting the best fit for their needs. But we also have another idea for an in-store shelf layout optimizer. Both sounds promising. So how we can decide which one to invest in?
That is a great question. And I think the thing that we have to start with is understanding that these use cases are very different in terms of the technical complexity. So let's take a look. The customer service agent can actually be built completely without pre-trained models. So you just enrich those models with your product data, your catalog data, your FAQ, and you don't have to do much. It's minimal custom development. But the shelf layout optimizer, that's a little bit more complex. You need custom 3D store mapping. You need computer vision models that's trained per location. That's a completely different scale of effort. So we need to think about not just the complexity, but the cost of approaching those.
And what about ROI, for example? Because a shelf optimizer could improve sales per square root, right? So
yeah, you'd think so, right? But if you really look at it, it's actually a very marginal improvement. So standard planogram software that exists in many stores today, it already handles layout optimization for you, right? The incremental gain that you'll get from AI may not justify that per store overheads in development costs and maintenance that you're going to need to deploy that. Meanwhile, the customer service agent can kind of like deflect over 80% of routine inquiries, things like stock checks and product specs and project advice. And it'll scale across all our channels without hiring extra staff for peak seasons like Black Friday. So if I look at this, the return on investment is going to be higher for the first than the second.
Oh, that's interesting. And so we can say that the lesson here is, the main lesson here is not every problem needs an AI agent, right? I mean,
100%. And I think,
right?
Yep, that has to be the thing that we start with every time. Just because there's AI doesn't mean you have to use it. Match your solution complexity to the problem that you're trying to solve. So in this case, the shopping assistant is a very clear win. Low cost for development, and it's going to give you a fast return on investment, and it'll scale. Shelf optimizer, it's a case where the traditional software you already have may do the job well enough. So you want to think about what your kind of trade-offs are before you dive into applying AI there.
That's helpful to know. So what about the other ideas, the other agentic ideas we have? How we can, which kind of roadmap we can build here?
So I love this table because, it's always nice you can evaluate against criteria. So let's score them against the 4 criteria that we're seeing right here, right? So first, I'm biased, but the customer service agent wins on all 4. First, let's look at the low implementation complexity. It turns out that we're using our existing product catalog, pre-trained model, low complexity. So we can actually get away with a lot of value. High financial impact. Again, the impact from reducing support labor because you've now got an AI-based customer service agent can be underscored. Short time to value. So here we can deploy using, and we'll talk about this later, using Copilot Studio in weeks with very little effort. So that's an automatic win for us right there. And last but not least, we're looking at internal champions. Anytime you do something, you want to look at the domain experts and say, what do you think? And we know that our customer service teams are already championing this because they see the value for it right away.
Cool. Yeah, that's, it's helpful. I do agree. It's helpful to kind of score each scenario across different metrics. But I think we need to go even a little bit more deeper than that. I mean, I trust you, Nida. I trust you 100%. But I think that there are some kind of additional things we need to take care about. So for that, let me go to to confirm our hypothesis and confirm our roadmap we have brainstorm now. Let's go to, let's deep dive into 3 specific things. So let's kind of answer 3 specific questions on the business perspective side. First of all, understand the key cost drivers. So how much all these agents will actually cost. Second, how we do justify investment to the board for each and every agentic AI solution. And third, what governance do we need? So let's start with the cost. And let's look at infrastructure cost first. Compute is often the biggest line item. GPU optimized VMs for training, for example, can be expensive. And Zava's strategy here is to use spot instances for interruptible workloads like batch training, which can save up to 90% versus on-demand pricing. Model selection also matters enormously. The customer service shopping assistant can use pre-trained models imported from Microsoft Foundry, for example, where you can find more than 10,000 different models. But other more advanced agentic architecture, like the return fraud detection agent, may need a more capable model fine-tuned on proprietary return and order data. So the cost of the two will be different. So the key here is to benchmark models in Microsoft Foundry before committing, so to not over provisioning. And for hosting, another best practice is to prefer platform as a service or software as a service for easier cost control and auto scaling, if possible, of course. Also, another thing to consider is that smaller models, for example, 5 models, Hugging Face, reduce training time and cost. So that's another thing to consider. In addition to infrastructure cost, there's development cost that go well beyond just training a model. So you need to account for the full development life cycle. So agent development, testing, integration, hosting. For testing, Zava can use Microsoft Foundry's built-in evaluation tools to run local or cloud-based evaluations on test data that might be also synthetically generated if you don't have an existing testing data set, and configure red team agents also to simulate adversarial scenario. Integration is another point, and is where costs can sneak up on you because every API connection, authentication layer, and data pipeline adds complexity, which means cost. And Zava plans to use the Microsoft Agent Framework for multi-agent orchestration, MCP, the Model Context Protocol for tool calling, which is a standardized protocol to enable the agent to integrate with external tools, and Azure API management to secure the endpoints. And for hosting, Azure offers multiple options based on the workload type. Microsoft Foundry Agent Service is the recommended option when using the Foundry models and Microsoft Agent Framework. In particular, hosted agents enable deployment of containerized agents so the same code can run both locally and in the cloud. But for more custom workloads, you might want to consider things like Azure Kubernetes Services that provides a flexible option for self-hosted agents with more control over scaling and cost optimization. Next, we need to consider data in terms of cost, because data quality is often underestimated, but it directly impacts every downstream cost. If a Zava agent retrieves duplicate records, for example, it wastes tokens processing them. So it's pure noise, and noisy data reduces model accuracy, leading to more errors, more human intervention, higher costs. So sensitive customer data and product safety records also trigger compliance overhead that must be budgeted for. And Zava's strategy is to invest upfront in a solid pre-processing data pipeline to automate normalization with Azure Data Factory, for example, optimize chunking for the model's context window, so to reduce the number of tokens in input to a model, batch process embeddings to minimize token costs and optimize research, and use Microsoft Purview for data classification and masking. So the investment in clean data really pays for itself many times over. Okay, so we covered infrastructure cost, development cost, data cost, but deployment is not a fine line. There's some other costs to take into consideration, and one of those is kind of related to people, so not just resources. Because Zava needs, for the development of the solution, Zava needs AI, ML engineers, data engineers to take care of the data pipeline, software developers, security specialists, and also UX designers. So Zava strategy is kind of pragmatic. They are going to start with a small cross-functional team for building the customer service shopping assistant, which is the agent we kind of identified as the prioritized one, and then and for that they can leverage PaaS or SaaS solution with less kind of specialized talent. But as they move to more complex agents like return fraud detection, where they might need to do some fine-tuning, for example, they grow the team and bring in deeper AI, ML, and data engineering skills. And they also plan to invest in upskilling their existing software developers, for example, training them on prompt-driven development, on RAG patterns, rather than trying to hire, for every skill gap. That's another good thing to do. And finally, there's the ongoing cost after deployment to take into consideration. And there are 3 major cost areas to manage continuously. First, token consumption, often the largest ongoing expense. Input and output tokens to a model are billed separately, with output tokens typically costing more. Then if you are fine-tuning your model, for example, the method you're going to use to fine-tune your model matters. Supervised fine-tuning and DPO techniques are charged per token times the number of epochs, for example, while reinforcement fine-tuning is time-based and includes a separate grading token cost. So a powerful strategy is something like model distillation, where you can use outputs from a larger model to fine-tune a smaller one. And second, so cutting both inference cost and latency. Then the other thing is performance monitoring, because we need to find kind of a trade-off between using monitoring tools like Azure Monitor and Application Insight that, of course, provide deep insights that could, identify regressions earlier, that could identify potential wastes of cost. But they generate their own data ingestion and storage costs, right? So we need to kind of balance observability with cost. And you can do that, for example, using sampling, setting smart retention policies, or starting with 3 built-in tools like Microsoft Cost Management before investing in advanced telemetry. Another thing is regular prompt efficiency audits can identify a token waste, and monitoring context window utilization prevents costly failures and retries. Finally, we have model retraining. That's another thing that might happen, after the deployment. You might consider to retrain your model, but only, for example, if your data changes significantly, or if the base model is deprecated, for example. What you can do is you can batch your training updates rather than running frequent small jobs, and also use developer tier, for example, for experimentation, since it avoids hosting fees. And finally, there's security and compliance, so things like automated vulnerability scanning, regulatory audit trails, and user support, which are ongoing needs. So Zava kind of budgeted 20 to 30% of initial development costs annually for all these ongoing operations we have seen. Okay, let's go to the next step, the next question. How we do justify the investment to the board. So we kind of understand, we now kind of have an understanding of the cost, but how do we justify the return on investment, so that it's worth investing in this agentic AI solution? So AI agent value comes into in 2 dimensions. First, the quantified cash flow impact. So the revenue uplift from things like better personalization, cost savings from automation, efficiency gains from faster workflows, and risk mitigation from catching return fraud earlier, for example, for that specific use case. So Zava will track all these KPIs like cost per interaction, customer lifetime value, and operational throughput. So this is for a cash flow impact, but second, there's also strategic and intangible value. So those values which are not quantifiable, they are more quality related. Things like better decision-making, improved customer experience, the ability to scale without proportional headcount growth, and also brand differentiation. So these are harder to quantify, of course, but are still strategic benefits, which are equally important for long-term success. Okay, now let's go to, I know you know that mathematical formulas can scare here, but let's do a practical example. That's the objective of this slide. So the general formula is to kind of calculate ROI is benefits minus total cost divided by total cost times 100. And total cost is made up of cost to achieve, so cost of deployment plus cost to maintain the solution. So let's apply it to the Zava's customer service shopping assistant, the first use case we want to prioritize. Zava estimates $80,000 to build and deploy this agent, $20,000 per year to maintain it, and $200,000 in total benefits over 3 years from increased deflection, conversion uplift, and support labor savings. So plugging these numbers into the formula, we get around 43% of ROI, which means that for every dollar Zava invests in this agent today, they get back about $1.43 over 3 years. And that's a solid positive ROI and a strong business case to present to the board, to kind of justify the investment. But there's another thing to take into consideration, because simple ROI, helps have an understanding of this agent is worth investing or not, but doesn't account for the time value of money, because a dollar today is worth more than $1 in 3 years due to things like inflation, risk, opportunity cost. And that's where there's another value that we can calculate, which is called net present value. In our Zava example, for the Zava's return fraud detection agent, for example, if the initial investment is $100,000 with expected annual cash flow of $30,000 over 5 years, if you use an 8% discount rate, which is a rate you can ask to your finance team that provides basically based on cost of capital, the NPV works out to about $20,000, a little less. So because the NPV is positive, this investment should be approved. And so this is the kind of rigorous analysis that builds credibility with your leadership team and the board. Okay, so we kind of have an understanding of the cost, have an understanding of how to compute ROI to make sure that this agent is worth our investment. Let's now look at some frameworks that can help us put all these things together. Let's say like that. So with the business case approved, Zava needs to kind of establish the right governance and operational frameworks before scaling. And so this module is going to cover the question, what governance and operational frameworks do we need? And we're going to start with the AI Center of Excellence, which is a strategic hub that standardizes AI development, fosters knowledge sharing, and ensure compliance across the organization. So Zava builds their AI Center of Excellence as a first step. They secure executive sponsorship from the CTO office, appoint a dedicated COE leader, assemble a cross-functional team, including data scientists, engineers, compliance experts, and business leader. And as they mature, they'll shift to kind of an advisory model where individual teams have more autonomy, but follow the standards the COE has established. So that's kind of the first step. Then the second framework I want to present is the FinOps framework, which brings financial accountability to cloud spending. So for Zava, this means every agent team can see exactly what they are spending and is responsible for optimizing it. So FinOps capabilities like cost allocation, budget forecasting, and performance to cost benchmarking help Zava identify when a model is underutilized, for example, when compute is over-provisioned, or when a lighter weight architecture would be more cost-effective. All these kind of things, all these kind of questions, the FinOps framework can help us answer and identify. The third framework I want to present is the GenAIOps framework. This adapts traditional MLOps principles to the unique demands of generative AI agents. So it provides a maturity model that helps organizations like Zava to understand where they are and what capabilities they need to develop next. For example, for our Zava's customer service shopping assistant, they might start at level 1 with model discovering and prompt testing. As they mature, they can move to level 2 by augmenting the model with prompt engineering, retrieval augmented generation pattern techniques, and eventually they can reach level 3 with advanced large language model workflows, proactive monitoring, up to level 4, where they have fully automatic monitoring and model prompt refinement in place. So this GenAIOps framework helps Zava plan their operational maturity in parallel with their technical development. And then there's another couple of frameworks. There's the Cloud Adoption Framework that provides the enterprise-wide guidance for cloud strategy, governance, and security, and the Well-Architected Framework that gives you 5 pillars to evaluate your AI agent architecture against. But I don't want to deep dive too much in other frameworks because Zava, as every other company, doesn't really adopt all of these frameworks, right? Because the point is to selectively apply what fits your maturity level. Every framework adds complexity, rules, cost, and so on and so forth. So they focus on the center of excellence first for the governance bit, FinOps for cost management, and generative AI ops to handle the operational specifics of generative AI. So things like prompt management, model versioning, evaluation pipelines, and responsible AI guardrails. And as they mature, they can layer in more. So that was for kind of my business perspective, Nidia. So I will hand over to you to kind of cover the engineer's perspective here.
Sounds good. I'm so glad you're the decision maker because that is a lot to kind of figure out. And I was just looking at this and I noticed that we ran a poll in the YouTube chat, and I don't know if you saw the results. It looks like what you said resonated with a lot of people because when they're looking at the biggest challenge for AI agent costs, I think 53% said it's controlling spend. And so this whole kind of like decision framework and understanding cost and complexity, providing ROI to stakeholders was at 19%. I think we have our kind of priorities right. But yes, as she said, now we've kind of decided, our decision makers have said, let's build. So what does the engineer perspective look like? So over the next few kind of slides and modules, we're going to cover 3 things. And these actually map to modules 5, 6, and 7. So from an engineer perspective, we're really looking at 3 questions. First, we want to maximize the efficiency by choosing the right development framework. So what development framework should we use? The decision is, should I build, should I adapt, or should I extend agents? Second, we want to think about how do we architect this in our Azure environment for scale and governance. So we're really asking, how should we be using the existing architectures and customizing them? And last but not least, we need to think about how do we manage and optimize that investment that we already made. So costs in production. So let's dive in and look at the first module. So in the first module, what we're really looking at is how do we maximize cost efficiency by choosing the right development approach. It's your build versus buy decision. And Microsoft actually offers 3 tiers of AI hosting platforms. First, we have software as a service. Oh yes, I should actually tell you when I'm shipping slides, Carlotta. Thank you.
No
we
worries.
have software as a service. We have platform as a service and infrastructure as a service, each with different cost profiles and skill requirements and levels of organization. So Zava needs to match their agent to the option that we have on the platform. And we're going to look through these right now on this slide. Here's the decision framework. With software as a service options like Microsoft 365 Copilot and Copilot Studio, you get the fastest time to value with the lowest barrier to entry. Licensing-based cost, no infra to manage. With Platform as a service, you're looking at options like Microsoft Foundry. Now that gives you more control. You get control over model selection, fine-tuning, and data orchestration. And the costs are now driven by your token and compute usage in this platform. With infrastructure as service, you're looking at using Azure VMs and Azure Kubernetes service, giving you full infra control at a higher granularity. And that will actually be seriously necessary if you are building highly regulated scenarios or when you need to run your own custom models. So the key is matching those use cases we started with, those scenarios, to the right tier that we need for that particular agent. We'll move to the next slide. So let's start with software as a service. We're looking at Copilot Studio. So if you want rapid deployment or development and deployment with minimal setup, Copilot Studio is probably going to be your best solution. With Copilot Studio, you can access a complete set of intuitive tools and capabilities in the full experience, or you can build agents with natural language right inside Microsoft 365 Copilot with the light experience. And what you really get out of this is the ability to kind of start fast, but then start using other tools, like you can customize those agents further with ProDev tools when you're ready for it, like the Microsoft 365 Agents SDK, Visual Studio Code, and of course the Azure AI platform itself. So for Zava's customer service shopping assistant, where we just want to get out there fast and use the data that we have, but use pre-trained models, Copilot Studio is a good option. Next slide. But let's talk about control. Platform as a service is when you want to kind of exert more control over the decisions that you're making. And so we're going to talk about Microsoft Foundry. Microsoft Foundry is a unified Azure platform as a service offering for enterprise-grade operations, model builders, and application development. So if you look at this, if you have a scenario that requires agents that use custom data, but may also need more controlled usage of the models, or the pre-trained models, you probably want to go here. This foundation it combines production-grade infrastructure with friendly interfaces. You've got APIs, SDKs, and various tools to talk to those platform capabilities. And now your developer can focus on building their application rather than having to manage infrastructure. And what Microsoft Foundry does really well is it unifies your agents, your models, and your tools under single management grouping with built-in enterprise readiness capabilities and an observability platform that I love, which includes tracing, monitoring, evaluations, and customizing setup configurations for your teams. Also red teaming. Now, the platform actually gives you a very streamlined management interface through unified role-based access control, networking, and policies under one Azure resource provider namespace. So not only do you get a kind of streamlined end-to-end developer experience, but your IT admins will also have a really easy way to kind of look at the entire ecosystem through a single pane of glass. Next slide, please. So we talked about platform as a service, but there is always option 3. What if you need to do even more control, for example, for governance, for privacy, etc.? This is when you would go to the infrastructure as a service option. And this is in the final stage of your build versus buy decision. So if you remember the use cases we had, one of our use cases were a product and safety compliance agent, right? So in this case, infrastructure as a service will make sense when you have highly regulated data requirements like that. You need full infra control, custom model hosting, and very strict latency requirements. So let's talk about Zava. Zava may need IaaS for their product and safety compliance agent because that is going to have strict regulatory requirements around things like hazardous materials data and product safety certifications. But there's always the trade-off. In order to provide the stricter governance, you are now going to also have higher operational costs, because remember that with IaaS, you manage everything. So the key trade-off table here is comparing Copilot Studio, which is kind of our software as a service option, where bring your model, give us the data. Just use the model, bring your data, and you're ready to go, with this extreme, which is where you control everything. And Copilot Studio will win on speed and simplicity, but it has limits on customization. Pro Code will give you full control, but requires more talent and time. So at the end, Zava's decision matrix is actually very simple. We had these 4 agents that we were thinking about. So let's take a look, based on what we've heard about these options, on what might be the best architectural decision for the agent. So for customer service, you want to use the software as a service on Copilot Studio. It gives you speed and simplicity. For the sales and inventory agent, where you want structured data analysis, you could use software as a service and then move to the platform as a service when you want more control. For the fraud detection, you definitely want to go towards platform as a service because you're going to need more model control. You might want to fine-tune for your particular use case, stricter evals, etc. And then for the product and safety compliance, where you really need control, you need observability into every nuance of what happened, you want to go into IaaS, infrastructure as a service, depending on, and you pick between PaaS and IaaS for the last one, depending on how strict your regulatory requirements are. But the lesson you want to take away from this is really simple. Don't default to the most complex option for every agent. Instead, look at the nuances of what the agent's doing and match the platform to the use case. Next slide, please. So that was kind of the module where we're thinking of what are the architectural decisions, right? But now let's look at what that looks like in practice. We've chosen our platform for the agent. So for the customer service agent, we're doing Copilot Studio. For the others, we're looking at Foundry, etc. Now we want to see how do we architect it to be cost effective. So you're asking, how do we design the Azure architecture for the platform that we chose? So in this module 6, we'll cover reference architectures, multi-agent patterns, and design principles, with the focus on scalability, governance, and cost efficiency. So this is where your developer has the highest impact. Your technical decisions are going to influence your cost and complexity. Next slide, please. So we're going to start first with your foundational kind of decision, Azure landing zones. So Azure landing zones are the foundation of Zava's architecture. They're defined, if you remember, we talked about the Microsoft Cloud Adoption Framework. They're defined within the Microsoft Cloud Adoption Framework. And what they do is they provide a structured environment that combines governance, automation, and standardized deployments. So in this diagram, you're kind of seeing a lot of stuff happening. But if you zoom out, you'll notice we're using a hub and spoke architecture with management groups organizing the various subscriptions. And of the 8 design areas that you see here, governance is the one most directly related to our cost efficiency. And I'm really happy to see that for 53% of the audience that answered our poll, cost efficiency matters. So this is where you define your Azure policies to prevent things like resource sprawl, enforce tagging for your cost allocations, and ensure workloads are right-sized. So Zava can use Azure landing zones to ensure that as they deploy those 4 agents, each one follows the same governance standards, has the proper cost attribution, and operates within the boundaries that you define. Next slide, please. So now that you've got your landing zone, how do you deploy your AI workload to it? So there are 2 approaches for organizing your AI workloads, and Zava can use a hybrid approach. So with the customer service shopping assistant, which was built in Copilot Studio, that just lives in an existing e-commerce platform subscription. It's simple and self-contained. All set to go? Start using that. But the other 3 agents, they're going to use platform as a service or infrastructure as a service, and they will need to share common infrastructure. Things like Microsoft Foundry, Azure ML, the monitoring tools that you're going to use across your entire solution. And so you want them to go into a dedicated AI application landing zone. What this does is it gives you centralized governance over all of those agents, despite the fact they may have slightly different architectures. You can then enforce consistent policies and share resources, for example, across your sales and inventory agent, your fraud detection agent, and your product compliance agent. And the baseline Microsoft Foundry chat reference architecture that you see over here gives you a trusted starting point. These are architectures that have been designed by the people who understand the trade-offs and have looked at the framework options and give you the basic capabilities to start with: a chat UI, data repositories, language models, and an orchestrator for your agents, all deployed with zone redundancy and high availability on the Azure App Service. Next slide, please. So What happens now when you've got all these agents? We need to start thinking about multi-agent systems and our cost strategies with respect to those. So there are many design patterns. And so as Zava starts scaling to more and more agents, they need to think about which pattern is right for the job at hand. So let's talk about what those options are. A parallel pattern is when the agents work simultaneously. It gives faster results, but higher compute costs. So you may use this in certain cases where, for example, you want to have the ability to scale to take advantage of multiple people asking questions at a high kind of load scenario situation. A sequential pipeline, a pattern, has agents that hand off to each other. Now, this is cheaper but slower, but sometimes that's the pattern you need when the second agent has a dependency on something that the first agent is doing. Zava chooses a hierarchical pattern with an orchestrator that takes the incoming request and then figures out how to delegate it to specialized agents. So this is your best approach to balance your cost with the capability. And for cost efficiency, they're going to follow 5 design principles. First, let's right-size the model for the job. In other words, don't just use the biggest, shiniest model out there. Pick the smallest one that will meet the quality requirements for that task. Second, cache aggressively. By caching, you can kind of like serve out frequently requested responses and avoid redundant inference. It not only reduces your token cost, but it will improve the latency with which those responses are returned to the user. Third, batch your requests when possible. When latency allows, make sure that you can actually have them be grouped to take advantage of things like batch inference pricing. Set quotas, set hard quotas to prevent runaway costs that you did not anticipate. And last but not least, tag everything. Once you've tagged your resources, you will get granular cost attribution. And these principles compound. Together, they will reduce your cost by 40 to 60% compared to a naive deployment. Next slide, please. So in our final module in the engineering side, we're going to ask, okay, we picked our platform. We kind of understand the design patterns for agents and the architecture. So once we've deployed it in production, how do we manage and optimize agent? How do we continue to monitor and refine this strategy so we are always controlling costs in production? So this is really covering what happens after deployment. Zava's agents are now live, but the work isn't over. We need continuous monitoring, cost analysis, and optimization. So Microsoft Foundry has built an AgentOps. Tools like those make this significantly more manageable for the average developer and IT admin. So let's look at the 3 pillars of production management. Next slide, please. Pillar 1, Azure Monitor and App Insights for monitoring. Monitoring always starts with Azure Monitor and App Insights. With Zava enabling App Insights on every deployed agent, they can now track 4 metric categories. They can track performance metrics like the response time and latency. They can track the reliability metrics like error rates and exceptions. They can track the usage metrics like conversion volume, number of active users, and they can track their dependencies, showing how their agents are interacting with each other and with APIs and databases. In these cases, you can see that the tooling that you use could be App Insights, distributed tracing, your own custom metrics, and application maps. So let's talk a little bit about what those actually mean. The application map feature is especially valuable. It visualizes all those dependencies so you can quickly spot bottlenecks. And this is actually super useful when you're in production because you may not know about the varying loads on your endpoint ahead of time. They set up automated alerts for any anomalies that you might not have expected. So the operation teams know immediately when something goes wrong. Real-time dashboards give your leadership visibility into how those agents are performing against the KPIs that they set up at their initial planning. Next slide, please. Then we need to have a way to look at our costs. So there's a cost management aspects of Azure where you can get granular visibility into your AI spend. So what can we do? With the cost analysis and metrics explorer, you can break down costs by resource, service, or tag. Remember the tagging that we recommended you do earlier in module 6? This is where all your early planning and instrumentation starts paying off. They set up cost alerts at budget thresholds, so there are no surprises. And the anomaly detection will catch these unexpected spikes immediately so you can mitigate them before they go out of hand. For a deep analysis, they can export the data to Power BI and Microsoft Fabric. Now, on the metric side, the Azure Monitor Metrics Explorer lets them correlate your infrastructure metrics with your agent performance. So each agent has its own cost KPI. The cost per conversation for customer service, the cost per insight generated for your sales and inventory agent, the cost per return claim analyzed for fraud detection, and cost per product safety review for compliance. So these are the kind of metrics that Zava can use to demonstrate their ongoing return on investment to their leadership. Next slide, please. And this is my favorite part, because nothing matters if you can't actually measure what you talk about and continue to measure it constantly to make sure that it stays in the zone and the expectations that you had set out. Microsoft Foundry's continuous evaluation capability is your game changer, especially for production AI agents. It will automatically sample and evaluate your agent interactions in near real time, measure quality metrics like intent resolution and tool call accuracy, which are specifically important for agentic performance. It will look at safety metrics, so it can detect unsafe responses, and it can give you quality metrics, performance, like latency and error rates. Now, in addition to the kind of like metrics you get from evaluations, the integrated tracing is actually super important for developers. It is powerful because when the issue happens, you want to know not just that it happened, which the alert can tell you, but you want to know where it happened and why. And with tracing, you can drill down right into the execution trace to find that root cause. And Zava enables continuous evaluation across all 4 agents with a unified dashboard, a single pane of glass that lets you observe your entire fleet. So from your kind of center of excellence, the center of excellence team is given a single pane of glass or a unified dashboard where they can monitor the quality, safety, and performance of their agent fleet, and then dive in and drill into any single thing that they find interesting to understand more. And this replaces what was previously a very expensive and complex manual testing and review process. Next, please. So what are the 3 levers that Zava is going to use? Because at the end of the day, we're talking cost, right? For cost control in production, we have 3 levers: budgets, quotas, and optimization strategies. With budgets, you can set monthly limits per agent with an automated alert, for example, at 50, 75, and 90% thresholds. Dev and test environments can have separate but smaller budgets. With quotas, you can set daily token limits per agent, set request rate limits to prevent abuse, and set compute quotas per team. So you have a fairly good idea of what your kind of like cost fences are, so to speak. For optimization strategies, you can right-size models, meaning periodically test whether a cheaper, smaller model might do that job more with comparable metrics. So you can switch it over. And they can use reserved capacity for predictable production workloads and spot instances for training. They can implement response caching for their customer service agent, which would handle repetitive product inquiries, save you costs, improve your latency. And they can have a process for pruning underperforming agents, which is equally important. You need to know when to deprecate the things that are not working. And sunsetting outdated models, so you're not paying for the things that are actually not actively going to be used. Combining these strategies can save Zava about 35% on their overall AI spend. And next slide, please. So we kind of took you on this massive journey. That was a lot, I know. But before we wrap up, let's just talk through, like, briefly, right? What did we cover today? We covered the full journey from a decision maker, or like first someone comes in with a requirement, a decision maker identifies the use cases and optimizing cost and production. What are the architectures? What are the decisions you need to make? What are the frameworks you can use, etc. And then we segued into, okay, we've decided to build this thing. So the first question you have to ask is, should I use agents? You decided to use agents. Okay, great. What are the kind of like decisions I make? Now let's build it. And we walk through the development process. So let's wrap up with the key takeaways from each module. And I'm going to turn it back to our decision maker, Carlotta, to take over at this stage.
Let's do one thing, Nitya. So let's see. first of all, thank you for bringing here the technical perspective. But let's do one thing. So, do you want to recap what I have presented in terms of business changes and responses, and maybe I can wrap up the technical changes so we see if we kind of understood the other point of view.
You bring up an excellent point. This is actually what happens in real companies. The two teams must talk to each other. So I need to understand as a technical person what the business folks are saying and vice versa. So let me recap what I heard from our decision makers. First, the key lesson I learned is use cases. We need to prioritize the use case by business impact and quick win potential. So we shouldn't try to boil the ocean. We should look at what can we do right now that gives us the fastest return on investment. Second, and this is, I think, one of the biggest things we're taking away from this is the cost drivers. Budget everything comprehensively. The infrastructure is just the one piece. People think it's the infrastructure cost, but actually there's data quality costs. There is people management costs. And then there's going to be the recurring costs for maintaining what you actually built. And third, I think this was to me something that I kind of got a lot out of, is there are rigorous financial frameworks like NVP, NPV, sensitivity analysis, and more that can help you take that kind of application scenario and convert it into a credible business use case. And never forget that the adoption rate is your most influential variable. Like if you build it and they don't come, it didn't matter. And then the fourth thing I think that I took away is that the governance frameworks, you need to establish them selectively. You don't need them all, just the ones that match your level of maturity. And I think that's what I took away, but maybe you want to tell me what you heard from me about development, Carlotta.
Yeah, 100%. And I'm glad the messages around the business perspective landed pretty well. So what I've heard from you is, first of all, we need to, there's different approaches, like there's different development approaches. And so the first thing we need to understand is for each agentic AI scenario, which development approaches is the best fit. So for a scenario like the customer shopping assistant, we could start with a simpler development approach like the software as a service approach, because we don't need necessarily, full control or full customization. We just need to prototype in a few weeks and have kind of a quick return value. As we go further, with more advanced scenarios, we might want to enrich our architecture, moving to platform as a service. For example, if you want to have more control on models, fine-tuning models, and those kind of stuff. And finally, the infrastructure as a service is the approach that enables us with the full control and full kind of customization, but of course also higher complexity. And then once you understand what's the development approach for each agentic AI use case, the next thing is building your architecture, like planning your architecture. And one kind of best practice is using Azure landing zones and use reference architecture, so we don't kind of reinvent the wheel. And finally, of course, developing and deploying an application is not a fine line. We need to make sure to productionize our application. We need to make sure that robust monitoring is in place. We have the tools to kind of monitor the whole fleet, agentic AI fleets of our company, so we can monitor budgets, quotas, and continuously optimize our application over time. How was it?
I think you did great. I'm surprised that in an hour we went from having 4 ideas to figuring out how to build a prioritized roadmap. So we should probably check if our audience learned about this too.
Yeah, let us know if you have any question, because we do have some questions for you. I'm going to paste the link to the knowledge check in the chat so we can quickly go to that. And you have an handy QR code in here as well. So if you want to kind of participate to the quiz, there's 5 questions for you. And of course, Nidia and myself will answer to the questions as well. So let me jump into the quiz. So the first question is, and again, here you have, let me refresh for a moment. And I show you again the link and the QR code. I give you 1 minute just to join the quiz. So here you have again the QR code and the link to join our quiz. And the first question is, which of the following is an example of a cost-effective AI use case? Or if you prefer, you can also just answer in the chat. So the first answer is a monolithic AI agent designed to handle all tasks in large organization. Second answer is a predictive AI system to manage stock levels for a small bookstore with 500 titles. And the third answer is an e-commerce chatbot that handles fax, order tracking, and returns for a mid-sized online retailer. Nidya, what do you think? What might be the correct answer here?
I'm probably biased here, but I have to go with C, right? And the way I think about it, the monolithic AI agent that handles everything, I don't think we want to really think about like our design guidance of use the right agent for the job. And this is trying to do everything. But I like that e-commerce chatbot because we're showing that there are clearly specialized tasks, a lot of things happening. E-commerce requires scaling and governance. I'm going to go with C.
Let's see then. Yeah. Good guess, or good reasoning. That is exactly the right answer, and it's exactly what Zava is going to do, right? Because they are going to prioritize the kind of customer-facing shopping assistant. So it's a similar scenario. I know we need to wrap up, but I have I spoiled this one, so let me go to the third one. Okay, so let's see.
So I'll turn this on you and ask, why is net present value important when forecasting ROI?
Yeah, so let's go with this one. We have, so it simplifies ROI by ignoring future costs and benefits. It provides a realistic financial view by discounting future cash flows, and it ensures that only short-term gains are considered. So, I mean, ignoring future costs and benefits, I don't think it's a great idea,
Yeah,
that's exactly what we want to avoid. So I guess that's not the right answer. It ensures that only short-term gains are considered. Well, we say that we are introducing net present value exactly because we want to not only think about the short-term value and short-term gains, but the long-term ones, because we say that $1 gain today is worth more than the same dollar gained in 3 years or 5 years.
Yeah.
So yeah, I would definitely go with it provides a realistic financial view by discounting future cash flow. And I can see that everyone here has answered correctly. So
thank you. Yeah.
Okay, so I know it's time. So let me go back. Thanks for answering, the questions anyway. I hope that was nice. And let me go back to our deck so we can kind of provide people with some next step and useful resources. So first of all, you have the Microsoft Learn path, and you have the link in the chat as well. But the other thing we want to share with you is you have here the link, but also the QR code to this slide deck. So this will lead you to a GitHub repo where you will find an HTML, PDF, and PPTX format of this deck. So whatever format you want to use, you have the choice. And then, so in terms of next step, you want to start to identify your kind of top 3 AI agent use cases. Build a ROI model to understand, again, if it's worth investing in Agentic AI for the use cases you have selected and prioritized, and start with a quick win proof of concept with your favorite tools that you can present to your board, for example. Anything else to add, Nidya, as to wrap up here?
No, I was actually going to say, since if you do go check out the repo with the slides on it, definitely, to answer those questions, we'd love to hear what their use cases are. They should just post it at issues on that repo if they can, and we'd love to hear what those are and kind of even like get some sense of which parts of this Learn module and Learn path resonated with you, and any feedback on, hey, I would have loved to have heard more about this particular aspect. That would be great.
Yeah, 100%. So thank you so much for joining us today. Hopefully it was helpful, and you have a couple of resources to learn more. Thank you so much.
Thank you all for joining, and thanks again to our speakers. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find our survey link on the screen or in the chat. And we'll see you at the next one.